Hi, it's Robin, and this is the patron exclusive for August 2020. I just recently made the video about fixing the game Dungeon on the PET. It wouldn't run on PETs with BASIC 4 as it relied on some quirks of BASIC 1 and 2. So if you haven't seen that, check out that video. I actually got asked if there was a dungeon for the Commodore 64, and surprisingly, I can't find one. There is one on GameBase 64, but if you take a look at it, it's actually the PET game, and if you run it on the C64, it really doesn't work much at all. The title screen prints, but the game is completely broken on there, so I don't know how that got added to GameBase 64. So I thought I'd try porting it from the PET to the 64, and I wanted to do that, but I also had to make the patron exclusive for this month, so I decided that's what I'm doing. So first I'll show you the game, and then we'll look through the various changes I made to the basic code. So here's the title screen. I tried to keep it close to the original, both because of time constraints. Can't really afford to spend a week or two converting this, so I was just going to do the best I could in a couple evenings. And also, I wanted to keep it in basic, not just because obviously that would be quicker and easier, but I wanted to preserve that ability to just list the program and take a look at it. So the title screen's basically the same, but I did add a number of instructions to the screen because how to play it isn't very obvious, making it a bit more self-documenting, especially with the new controls that I've added, I thought were important. I also added the credit at the bottom of the title screen to myself, not really just as like bragging rights, but also it's a piece of the history of the game to make it clear that Brian Sawyer made the original in 1979, and then this version was updated. It's kind of, who knows, sometime in the future, people might load this up and then just be unaware of the history of the C64 port, for example. So I just think it's always good to include those sort of comments. Again, not to brag, but as part of the lineage of this game, part of the history of it. So as you probably see from the title screen, I mentioned the joystick. So here I've got a joystick plugged in. I'll press the fire button to start. So you also see that I added some, well, I didn't add color. Basically, I just set the background to black and the character color to green just to mimic the PET. However, I left the default Commodore 64 font in. It's technically possible to use the PET font, but it doesn't look so good on composite video. And also that would be a bit tougher to actually use that font and still keep it a simple basic program that you can just list. Well, I'd have to add another file or whatever. Anyway, with what I've done today, I'm sure many people will have opinions about how I could have done it. I could have done this or that or whatever. But the beauty is it's in BASIC. I'm providing the program file, and you can go ahead and make any of those changes you want. Okay, so our dungeon's generated. We'll just play it a bit so you get an idea. You may move. So there's a spider right there. I'll just move down on top of it to attack. It automatically fights. Okay, the spider has 25 hit points, and I only have 20. So I might actually get killed right away here, but I'll risk it. Press the fire button to attack. The spider has 15 hit points. I've got 13. Now he's attacking me again. The spider has 7 hit points. I may move. Going for it. I've actually never had a fight like this before. I'm dead. Okay, and there's the dungeon uncovered. Okay, and another thing I did was when these prompts come up, like want to play again, if you push up or right, it automatically puts a Y there. If you push down or left, it puts an N. So you can play with the joystick, but I also preserve the ability to just hit Y or N on the keyboard, if you like. Just press the fire button to confirm that. Okay, now we got another 60-second wait. I'll fast forward this. All right, here we go. So again, here we've spawned, and you just move the joystick in the direction you want to move. And it reveals the dungeons. There's a dragon with 18 points. I got 49, so it should be an easy fight. The dragon's dead. The experience goes up, and my hit points, wow, jumped all the way up to 120. Apparently you level up whenever you more than double your former experience. And when you're at 0, of course, well, it's like infinite. So it levels up and gives you extra hit points. Okay, we seem to have spawned in a room with no exit. So this is both a gameplay feature, but also kind of like a bug. Well, not really a bug, a limitation of the dungeon generation. It doesn't guarantee that all rooms are connected. It just strictly sticks with that 60-second limit. And if not all the rooms get connected, so be it. So that's part of why this feature to phase or walk through the walls was added. On the PET version, you held down Shift. So I've made it so the fire button combined with moving the joystick lets you walk through. So I'm going to push and hold the button at the same time. Okay, there's a room down there. Gold is near. And we'll grab the gold. You found 1 gold piece. And there's a wyvern, or is it a wyvern? Wyvern? With slightly more HP. We'll just try attacking it. Okay, I'm a little ahead here. I hope I win this fight. I don't want to have to start another game again. Yay, the wyvern is dead. And my HP's gone up again. In the original PET game, used the number pad 1, 2, 3, 4, 5, 6, 7, 8, 9 as a sort of like a D-pad, as I mentioned. 5 lets you rest and just like skip a turn and heal a little. So I've mapped that just to the fire button. You see my hit points have gone up from 75 to 77, 79. So you can actually just sit there and repeatedly heal if you want to take the time. But I made it so you have to press the button once each time, so you're not kind of like, just cheating. It's too easy just holding down the fire button to heal up. So is this another room that's not connected? Wow. Okay, so off we go again. Holding down fire to, you see how the HP is going down. That checkerboard is a door, and those stop monsters from going through. There's only 1 monster generated per room. There's gold again. There should be a monster in here somewhere. That's the edge of the dungeon, that checkerboard. And I'll attack that spider. The spider is dead. More gold. There's another doorway. Oh, it grew. I'll actually go back out. Only 1 monster can be active at a time, so he's going to keep wandering around. I'm going to heal up so I have more HP than him. Attack. The grue is dead. You might be eaten by a grue, but not today. $14 gold. And that's another doorway. Sometimes the doorways go into the room, one character like that, and that's because the hallways are plotted separately, and I guess that routine could be improved a little. Oh, lots of gold here. There's a snake with a lot of HP. Okay, so I think that's enough for the gameplay. You get the idea? I'll hit Q, just again to reveal. I don't know if I showed that, but pressing Q reveals the dungeon. And do you want to play again? We can move the joystick to no, or I can just press N on the keyboard. And there, we drop out to basic. I'll remember to change the cursor to white. And while I have the C64 version loaded up, we'll take a look at some bigger blocks of code that I added, and then we'll go back to the PET version and I'll actually make some of the changes just so you get an idea. So I'm not typing in all my changes. So if we list from 62,000 to 62,087, and this is just the title screen. Now obviously I'm not going to type all this in live again, but here's the additions I made. Adding the joystick, I followed their pattern of using the reverse mode to highlight certain phrases like move plus fire, or over here, fire to heal, and so on. And there's my low credit. Okay, simple stuff. Another block of code I put in at 63,000. This is all new. Just to initialize, here's where I poke the screen colors so it's black border and black background, and change the print color to 5, which is green. Notice that they're in the same order on the keyboard: black, white, red, cyan, purple, green, but the keys on the keyboard are 1 based, while the pokes are 0 based. So you subtract 1. So if you want green, it says 6. That's actually poke 5, 1 less. And then I make up this array called K for keyboard, and just read these data statements in. This is an array that maps the joystick, although it only has 8 valid positions because each direction is a switch. So that's actually 2 to the 4 or 16 different combinations of the joystick, but some of them are invalid. And so I've just gone through here and mapped for each of the 16 possibilities. I've mapped what key on the numeric keypad, as 1 through 9, it represents. And in all the invalid cases, I put a 5, which is the rest value. Originally I had zeros in this array, but 0 isn't a valid keystroke. And just in case you have a broken joystick or a joystick wired up so you can actually push left and right at the same time, for example, it was safer to put 5 in rather than 0, which actually might crash the program. When I worked on some Game Boy Advance and Nintendo DS games, Nintendo actually had part of their quality assurance. They would actually run my code on a broken Game Boy where you could mash the buttons, like push left and right together, and they would reject the game if it crashed or did any, or if it had any particularly bad results. So anyway, I learned from that. So you see each of the keypad numbers represented once on here, except for all those multiple 5s. 1, 2, 3, 4, 5, lots of them, 6, 7, 8, and 9, representing each of the valid player movements. Okay, now to load my program dungeon40.prg, which is the fixed PET game that I had worked on in that episode. And let's take a look at that. This is the original PET code here, well, with my small number of modifications I went through in the previous video. So notice that a basic PET program can be loaded directly on a Commodore 64 as long as it's a BASIC 2 program. If it's BASIC 4 or BASIC, well, if it was a Commodore 128 program, BASIC 7, those have additional tokens, sort of like opcodes, the single bytes that represent the various BASIC commands. BASIC 4 and 7 have extended tokens that the Commodore 64 will be confused by. But other than that, you can load BASIC programs between various Commodore 8-bit machines. It's pretty neat, really. So I've loaded in the PET program, and just so you see what happens here, run. So the title screen does display, But if I press return, you see it crashes almost right away in line 200. So one of these values, actually I think I, print I, let's try and poke 32 into location 65536, and the maximum location you can poke is 65535. So we'll go through and make all the changes necessary just so that the game does run on the 64 without error. And then the second phase will be doing the various joystick fixes to improve the controls. So let's go through them one by one. First thing we'll do is just get rid of this opening line, this clear instruction. I don't even know why a program would start with clear, because BASIC automatically does that. Maybe BASIC 1 didn't, or maybe Brian wasn't sure just to be sure. I don't know. And this poke here, I believe, sets the PET video chip to uppercase mode. It may have some other effect, but no matter what, we don't want it on the 64. So to get rid of that line, we're just going to delete it. Just type the line number and return. And now it's gone. Now the program starts at line 1. That was easy. Now the next change is here on line 80. Patron CS Bruce noted that my solution, this is lowering the top of basic memory by 4 pages right here. That is 4 times 256 or 1024 bytes. And he noted that every time you run this program, it's going to lower the top of memory another 1 kilobyte. And you're just kind of like losing RAM every time you run it. So that's not optimal. I did that on the PET because it was the simplest way to accommodate different size PETs. If you try to run this on 8K, 16K, 32K PET, this will work the first time you run it. Now, a lot of people will only run a game once, then they'll switch off their computer and turn it back on. But anyway, I agree that it wasn't the best solution. So instead, all I'm going to do is just hard code it in a way. Oh, P, haha. Okay, so P. So I'm going to just change that to poke 156. The default is 160 is the top page of BASIC on this Commodore 64. That is, the top of memory is set to A000. A0 in hex is 160 decimal. It's actually 1 byte beyond the top valid byte. So I'm just going to set that default 160, instead I'm going to poke it to 156. And that will eliminate that problem of it decrementing over and over again, of losing a kilobyte every time you run. And then I'm going to go sub that 63,000, which is that keyboard setup routine that I showed you with the array. And since we're setting the top of memory lower by 1K, well, that's where we're going to store the dungeon map. The little routine when you try to quit the game is at line 1400. Here's the end of the program. So we're just going to poke QM plus 1, comma 160, just to put it back how it was. And just good practice to do a clear after to clear any variables, then the end of the program. Okay, continuing on with the changes. At the end of 90, this go sub 62,000 actually goes to that title screen and waits. Now I noticed while on the PET, you got a random maze every time you ran it. On the C64, you actually end up with the same maze every time. So what you need to do on the 64 is just call the random. So you just have to assign it to a variable like rs equals rnd. And as a parameter, send in negative TI. TI is the jiffies since boot. And so this will be a different seed every time you run the game, because the title screen displays and it waits for the human operator to, press a key or press the fire button to start the game. that introduces the human element of a variable amount of time, and then we seed the random number generator by putting a negative value by making the time a negative value. Whenever random is given a negative number, that reseeds the random number generator. And then that way we'll get a different dungeon every time the game is played, as long as the user does wait a variable amount of time before hitting fire. You can't call these basic functions without the value being returned somewhere. You could print it to the screen, but I'm just a scientist at variable RS, which you could say stands for random seed, but actually I just chose it because RS is the next variable. And not that it should really matter, but so I'm not messing up the order that the variables are defined in. This actually stands for, I think, rows, 23 rows. So coincidentally, RS is also good for random seed. Yes, I'm probably overthinking this. Next are all these lines that I left just commented out in the original. This was the original bad hack. It was kind of like a memorial that I left it in there. But this was the main cause of the bug on Basic 4, was this dungeon array being dimensioned. So anyway, just to save a bit of space, I'm just going to get rid of those lines 130, 140, and 150. Gone. Okay, the next group of problems all has to do with memory locations being hard-coded. This AX stands for the location of screen memory, and it's set to 32768. Sorry about the wrapping around. So on the Commodore 64, screen memory defaults to 1024. So while it is possible to move C64 screen memory up to 32768, that requires some other setup. I decided to just go with moving it down to 1024, the default 64 value. I guess it could have gone either way on it. There's a bit of trouble either way. By the way, it's possible I'll make a mistake during this, but I will put the program as a link in the video description so you can download it yourself and check it out. And that program is going to be the final word. I might even update that after I make this video if I learn of another bug that I created. But anyway, this video should still be a good guide overall. I'll add a note in the video description if I change anything substantial. Another change is here, GOSIB 380. This calls the dungeon generation routine. And this was a nasty bug to track down. I think this is in the original PET version as well, but I don't know why I never saw it affecting the PET version. But on the 64 version, while I was working on this, every once in a while this monster would appear way up here on near the top of the screen, top row or second row, and it would just be moving along, even though I hadn't even unveiled that part of the dungeon, and that monster shouldn't even be active. And I finally traced it down. This must have taken me a whole evening, actually. This S equals 0 is used as a flag, or like a counter, for whether a monster is active. Actually, the E is the screen location, but 0 base, the offset into screen memory. E is the enemy position, and S is whether it's active or not. So normally an enemy at location 0 would be up in the score area of the display, right up here in the top corner, and therefore inactive. So I finally figured out that even though S is set to 0, it should be inactive. In the code for the dungeon generation, we'll find it here, 520, it's using S as just like a temporary variable for setting up one of the rooms, and it's actually assigning S a random value and not setting it back to 0 again. So this misuse of this S variable leaves a monster active even though it's up on the top border in certain circumstances. So you start a game and there's that monster wandering the top of your score display. Anyway, that was a horrible bug. But the simple solution for it, after you call the dungeon generation, simply set S back to 0, and that's it. So there's a 41-year-old bug that's been lurking around, fixed. I suppose we could delete it here too. Whatever. Okay, moving on. Around line 620 were a couple more hard-coded screen values. Instead of using the variable AX, it's a hard-coded value here. So I just went with it. I guess I could change this into AX -1, but instead I put 1023, that is one less than screen memory. I think this is slightly faster to parse this than to add in that variable AX and then subtract 1 again from it. Parsing constants is slow. It's probably still faster than parsing a variable and a single digit constant. I guess we could benchmark it. Feel free to do that if that matters to you. Again, you have the code too. 32811. So I calculated the offset for that instead from 1024, and that changes to 1067. And this location is 1000 greater than the screen address. So for us, that is now 2024. And sorry about the white space. It does run marginally faster. Here, just for you today, this isn't how the program will be. There's that slightly more readable. I don't even really think of it when I'm reading this kind of terrible no white space basic code, but I realize for some of you it's probably pretty annoying. So another reference I found was checking screen memory. I'm not even entirely sure what this line of code does, but anyway, it's screen memory. I'm going to change it. And now 60,300 and on. And this is the section here that was checking for either basic 1 or basic 2. On the 64, we don't need that check at all. So I'm going to get rid of those first couple lines, 60,400 and 60,410. And because it no longer exists, 60,400, I'm going to change that to 60,420. And then these variables point to various zero-page locations that C64 BASIC and the kernel use. I believe that's how many keys there are to read in the keyboard buffer. On the PET, 158. On the C64, that changes to 198. I used my transactor reference, which is excellent, the Complete Inner Space Anthology, which I did a Patreon exclusive video about a while ago. I used that to look up these values to convert them. And QM is that top of memory that we've poked already. On the 64, that's location 55 nearby. And QP changes to 203. So this is where the keyboard scan can be found. Okay, that's our first pass. Now the game should run. Let's give it a try. Oh! Okay, it turns out that I need to just add one line here. I was trying to avoid having to type all this in. 53280, 0 is just to set the screen memory. And return. So we'll run that. Okay, and the title screen hasn't been updated. Basically, I'm just trying to show you what happens when we do all the required memory-related fixes, but we haven't done any of the joystick or the cosmetic things like the title screen. So we're starting the game. Again, we'll skip this. Okay, so there's the game now working properly on the 64, but the big problem is it still expects us to use numbers 1 through 9 for movement, where 1, 2, 3 would be down and left, down, down and right, 4 would be left, 5 rest, 6 right, and then 7, 8, 9 to move up. So let's try that. We'll go down 1. You can see it's working. We'll press 4 to go left. Press 8 to go up. There's some gold. 9 to go diagonally. I found a gold piece. 1, 4. Okay, there's a snake. And 1 to attack it. Oh, snake has 22 hit points. Attack. 6 and 6, another close one. You may move. I'll just try attacking him again. Oh, press 5 to rest. Attack. The snake is dead. Yay. There. Hit points up to 12. So, you get the idea. Do you want to play again? No. Okay, so we'll list from 1260 on. So this is the main keyboard reading loop here, where we get L string, that's a single character. If it's null, then we go back to 1260, and this is just a short loop that waits. It says you may move, waits for a keystroke, and just sits there. And we convert that key into its ASCII equivalent, into A, and there's this variable SX. This checks, is the ASCII value of the key pressed above 127? If so, this statement returns a -1 is true. That's a kind of a quirk of Commodore BASIC. -1 is true, 0 is false. So this is like a Boolean truth statement. And then the ABS is the absolute value. That -1 turns into a +1. So basically SX will be 0 if the value was below 128 and 1 if above. And that's essentially is the shift key held down. And that's for that wall walking feature. If the user holds down shift while pressing the keys on the keyboard, they will have 128 higher on the PET. And then A gets that high bit, that shift key essentially masked off with this A and 127. Then we check, is the key pressed equal to 5, rest? If so, then we increase your hit points by 1 plus the square root of your experience divided by HP. It's just a formula. The higher experience you are, the quicker you'll heal. And then we check for the ASCII value be between 48 and 58, non-inclusive. If so, then we subtract 48 to change the key number down to a value between 1 and 9, and we go off to this other routine. Actually, there's this funny little line here. Michael Chajowicz, who made the Python re-implementation of Dungeon, I think he's correct here that if you press the S, it's like a scan feature, but it is incomplete. It'll cost you 2 HP and set this SM flag, see more perhaps, but it is unimplemented in the game. Well, actually, there's a funny bit of code. I'll show you that in a moment. And then if you press Q. So basically this is the main keyboard loop, and we want to inject joystick reading in there. And so first I'm just going to show you that one line, 610. This is that see more function. If see more is set to 1, then it does this funny business here that I don't really understand and sets that SM flag back to 0. And what this does is if you press S, you can actually see 1 square more to the northwest, to the up and left, and that's it. It's kind of like a feature that he meant to include and either forgot or couldn't figure it out or just had to ship it, but he left it in. So anyway, I've actually deleted that in the final version because it's basically useless. Again, you can type it back in if you want it there. Okay, so we'll look at how the joystick is implemented for that routine. So here we are on the 64 version. So we still get from the keyboard so that we can do that cue function. I've added this variable last joystick, LJ equals JY. That was the last move that was made on the joystick, and we're stashing that. We need it for a comparison later. And then we read the joystick. Peak 56320 is joystick port 2. And we AND that with 31 because we just want the low 5 bits, which are the 4 directions plus the fire button. And because we're reading both the joystick and the keyboard now, if else string equals null and JY equals 31, the joystick's not being moved at all, then we loop back. So this is just like before, except we're also reading the joystick, and if either the keyboard or the joystick is pressed, then we'll continue on. Now note that I didn't leave keyboard controls in. The numbers, the number pad obviously is a no-go. I thought at one point about using like IJKL or WASD, but you know what? For doing 9 directions, those are really a pain. Like, I just really don't like that. On the number pad, it's all lined up square, but going from U down to this comma, I just find that very unergonomic. Plus, it was kind of like a pain to map these keys back also to the numbers 1 through 9. It could be done. Again, you have the code. Go for it. Just explain why I didn't do that. It just seemed ugly to me. There's a nice 3x3 block on here. So instead, we check, this is that shift right here, SX, to see if they're doing the wall phasing, the wall walking. And instead, we're going to compare the joystick. If the fire button is held down, then JY is going to be less than 15 because we don't want to include the fire button on its own. That's a separate function for resting. So basically, if you press the fire button down, it subtracts 16 from JY. And in fact, on basically all I/O ports, if the switch is open, you get a 1. And if it's closed, you get a 0 on that bit. Okay, and then once we've determined the shift bit, then we mask off the fire button and put it into A. And that gives us, instead of a value from 1 to 9, a movement value from 1 to 9, or actually from 48 to 54, I think it was in the original, we're going to have a value from 0 to 15, representing the 16 different possibilities of the joystick movement. And here we're checking, this is like pressing 5 for the heal function. If the joystick is currently 15, that is, it's not moved and the fire button's held down, no direction is held, but the fire button is down, and previously that wasn't the case, then we'll heal. And that's just to make it so they have to keep pressing the fire button each time. And then finally, if the joystick is being moved some direction, then we're just going to use that array that we defined down at the bottom of the program. We're going to feed A into it as the current joystick direction from 0 to 15 and pull out the keystroke 1 through 9. So we're just mapping it back to the number direction, and then we can call the original routine that handled the keystroke without making any further changes. Okay, so that's how I put the joystick controls into the main routine. Now we'll look at the yes-no feature. Okay, and back in the PET version, let's look at this one other section. This routine here gets the keystroke, L string, I suppose letter. This is the short routine that waits for a yes-no prompt. And it's called both if a monster wants to negotiate with you, they'll spare you if you give them half your gold. And I recommend you almost always say yes if that's offered to you because you're going to die otherwise. And when you get game over, if you want to play again. So this, in a rare example of reuse of subroutines, this routine actually does get called twice for the yes-no. So we're going to want to interject joystick controls into this part as well, because it's kind of bad form to have a joystick version of the game, but you still have to reach for the keyboard. So this is just a little routine that blinks the question mark. It's just using midstream to either print a question mark or a blank. Grabs one character from it. So it's like a flashing question mark. And when you actually do type yes or no, then it prints it out and returns here. Now we'll look at the code for the 64 port. Okay, so here we are back on the C64 version with the joystick support. So I've added making sure that L string is set to null for the keyboard reading. Then we're going to read the joystick just as before and just take the low 5 bits. And if the JY is 15, that's again the fire button is held down and L string is not equal to null, that is there's a yes or a no in there, then we return from the function. And this is because I want to add both keyboard and joystick compatibility to this yes-no feature, because it seemed kind of goofy when it prompts you yes or no. People want to press Y or N sometimes. So now I'm going to get a string. This is to read the keyboard. I'm not putting that directly in L string, and if it's not null, that is, hopefully they pressed Y or N. The original routine actually didn't check for Y or N either. The actual calling routine just looks for Y for a positive and any other key is negative, so I just matched that. So if some key was pressed, then we are going to put that in L string, and then we will just do this print routine and print yes or no, just to give that little bit of feedback, and then return. So we're done. That handles the keyboard case. Then these are brand new lines where if the joystick is held, if JY is 23 or JY is 30, that is up or right, then set the L string to yes. And if it's 27 or 29, that is down or left, then set it to N for no. And both cases we go up to 1550, which is this print routine. And that allows you to push the joystick up or down. It will print Y or N here. These are backspaces just to go back over. So we can print and move the cursor back so we can update it. And that allows you to move the joystick, show yes or no, but not immediately confirm it. Wait for the fire button, just show it on the screen. So we return. And then here's the same routine as before that flashes the cursor and finishes the loop. So that was my solution to allow both immediate keyboard or move the joystick to put yes or no, but then fire button to confirm. That wraps it all up in there. Okay, so that is done. There's lots of other improvements that could be made on this, but like I was saying, I can only spend so long. I got a lot of other videos to make. I need to move on. I hope you enjoyed this. Make sure you download the program and give it a try. Okay, thanks for watching. Thanks for your support, and we'll talk to you next time.
Going to the dungeon, that's what they called it. Down in the basement at the university. Going to play rogue on the terminals. Just 10 years old. My aunt brought me. I just wanted to play ROGUE. Didn't know any other way. Delving in the caverns, fighting all the monsters, searching in the corners, gathering the treasure. I was looking for the amulet of Yendor. It must be down here somewhere. I just wanted to